Welcome to mathmarvelasmr. Today our topic is based on integration, but it's special type of integration that's a part of by parts actually. That is integration of e to the power ax into sine bx dx or e to the power ax into cos bx dx. This type of integrations we will solve today. We will prove, and after that we will take some examples to elaborate and make our concepts clear. Now let's go. First we will take e to the power ax sine bx into dx. Let it be equals to I. Now according to the formula of by parts, we will take e to the power x as the first function and then integration of sine bx minus integration of ddx of e to the power x into integration of sine bx dx whole integration of dx is equals to e to the power x into the integration of sine bx will be equals to minus cos bx divided by b minus of differentiation of e to the power x is equals to e to the power x into a into same will be there minus cos bx by b dx. Now minus 1 by b e to the power ax cos bx minus minus plus, and we will take a by b outside of the integration, then we will get integration of e to the power ax into cos bx dx. Now we will further integrate this second part following the same rule, then we will get e to the power ax integration of cos bx dx minus differentiation of e to the power ax into integration of cos bx whole integration dx. So now you will get minus 1 by b e to the power ax cos bx plus, now it will be a by b into e to the power ax into, now the integration will give us sine integration of bx a divided by the power ax and then minus a into b will be sine bx by b minus into dx a by b. So we will get 1 by b e to the power ax cos bx plus a by b square e to the power ax sine bx minus a square by b square integration of e to the power ax sine bx dx, which is equals to I. So I is equals to 1 by b e to the power ax cos bx plus a by b square e to the power ax sine bx minus, the interesting part is now it is a square by b square into, this is nothing but I. So we will get I plus a square by b square into I is equals to a by b square e to the power ax sine bx minus 1 by b e to the power ax cos bx. Now take I common, we will get 1 plus a square by b square is equals to a by b square 1 by b square into e to the power x e to the power ax taken common, so we will get a into sine bx minus b into cos bx. Thus we will get I into a square plus b square by b square is equals to e to the power ax by b square into a sin bx minus b cos bx. B square will be omitted, and now we will get I is equals to e to the power x divided by a square plus b square. Inside bracket it will be a sin bx minus b cos bx. Now this is one of the formula of the given question. We have proved this. From this step we will get the another format where we will take a common from the total part in the bracket. So we will take a common. It will be sine of bx minus b by a cos of bx. Now we will let b by a is equals to tan theta. If so, then we will get theta is equals to tan inverse b by a. Keep it in hand and we will utilize it further. Now I is equals to e to the power ax divided by a square plus b square into a. Now it is sin bx minus b by a is equals to tan theta into cos bx bracket close. Now I is equals to the power ax divided by a square plus b square into a. Now tan theta can be written as sin theta divided by cos theta into cos bx. So thus we will get I is equals to e to the power ax divided by a square plus b square into a. Now if we do LCM we will get cos theta into sin bx minus sin theta into cos bx divided by cos theta. So cos theta will be outside and that will be a divided by cos theta, and the inside part will be in a formula that is sine of bx minus theta. Now from our previous assumption tan theta equals to b by a will give us cos theta as a divided by root over a square plus b square, and sine of bx minus theta will be written as tan inverse b by a. Now is equals to e to the power ax. On simplification a will be omitted and this will provide us root over of a square plus b square into sine of bx minus tan inverse b by a bracket close. So this is one of the formats of the given question. So two different ways and different formulas from a given particular question we have derived. Now similarly from our this derivation we can easily write that e to the power ax cos bx into dx on integrated it will be e to the power ax divided by a square plus b square into a cos bx plus b sin bx plus c. And obviously in all of the previous formats there will be C, there will be C. And here it is followed by C. Now on the other hand, following the next format we can get e to the power ax divided by root over of a square plus b square. It will be cos of bx minus tan inverse b by a. Thus we can get this. Now if the format became integration of e to the power ax sine bx plus c into dx, that will be followed in the same way since c is constant, not related to any variable, so we can directly use the given formula, that is a sine of bx plus c minus b cos of bx plus c, and the format will be fixed as earlier we have derived. And same for cos bx plus c into e to the power ax dx, that is equals to e to the power ax divided by a square plus b square into b cos a cos bx plus c plus b sin bx plus c plus a constant. Now we will take some examples. Let's take some examples. One of the given question is e to the power x into cos square x dx. We have to solve this. Let's try. Okay, first manage this by multiplying it half in the external part, and then we will get 2 into cos square x dx. So it will be half of integration of e to the power x into 2 cos square x will be equals to cos 2x plus 1 into dx. So first we will break it. The first part is half of integration of e to the power x cos 2x dx plus half of integration of e to the power x into 1 into dx. So in the previous part, in the first part, we will directly use the formula here and we will get e to the power x divided by, here a is 1, that is 1 square, and b is 2, that is 2 square, into a into cos 2x, that is 1 into cos 2x, plus b into sin 2x, that is 2, because b is 2 here, plus half of e to the power x on integrating, e to the power x on integrated, we will get e to the power x plus c. So the answer will be e to the power x divided by 10 into cos 2x plus 2 sin 2x plus half of e to the power x plus c. That's it. Now take another example. Now the question is 1 by x cube into sine of log x into dx. Now this question is not just as same as our given question, given proof, but still we will manage it and let's see what happens. Now let log x is equals to z being differentiated, we will get 1 by x into dx is equals to dz. Now dx is equals to x into dz is equals to x is nothing but e to the power z. We can derive it from the assumption, that is e to the power z. So now 1 by x cube, since x is equals to e to the power z, so x to the power minus 3 will be equals to e to the power minus 3z. So e to the power minus 3z substituted. Now sine of log x will be z, so sine z, and dz will be equals to e to the power z into dz. Now once simplified, it will give e to the power minus 2z into sine z dz. Now just compare this with the previous formula, the standard one, which is e to the power ax into sine bx dx. So here a is minus 2 and b is 1. So we will use the formula here, e to the power ax, that is minus 2z, divided by a square plus b square, inside bracket it will be a into sine z minus b into cos z, b is 1 here, plus c. Now just we will simplify it, e to the power minus 2z divided by 5, inside bracket it is minus, okay, plus c. Now we will just substitute z with log x. Now we will get equals to minus 1 by 5 e to the power minus 2z means 1 by x square. Now inside bracket it will be 2 sine, sorry, it is 2 sine of log x plus cos of log x is equals to minus 1 by 5x square twice of sine log x plus cos of log x, and plus c obviously will be there. This is the answer. Now take another example here. Integration of x square e to the power x cube into cos of x cube into dx. Now here we will assume x cube as z, so it will be 3x square into dx equals to dz. After being differentiated, we will get x square dx is equals to 1/3 dz. So here we will substitute x and make the integration depending on z, that is e to the power x cube will be e to the power z to cos of z into x square into dx will be 1/3 dz. Being simplified, 1/3 will be outside. Integration of e to the power z into cos z dz. Now this format is known to us. We will apply the previous formula and find the answer and then substitute z with x cube. So ultimately the answer will be e to the power x cube divided by 6 into sine of x cube plus cos of x cube plus c. You try to see that this came or not. This is our today's explanation about e to the power x into cos bx or e to the power x into sin bx. So that was a nice time while explaining this to you guys, and thanks for watching till end. Thanks to mathmarvelasmr family, and stay tuned for the further uploads. So bye bye for today.